Greetings everyone, and welcome to Season 2 of Panhead Mania. Man, it feels good to be back working on the Panhead again. I'm a little behind schedule, but I'm having a lot of fun, so it really doesn't matter. I wanted to start this season off by showing you a couple of interesting old tools. And the first is this pole shoe tool that was probably state of the art 50 or 60 years ago. And it's designed to get these stubborn screws out and in while supporting the pole shoe on the bottom. The idea is you run this wheel down and it applies pressure to the screwdriver bit at the bottom. And then you use a T-handle or suitable tool to actually turn the screw. The nice thing about this tool is it allows you to finesse the field coils in. New field coils like these aren't arced to the generator frame, and there's a fair amount of resistance, and they require some persuasion, gentle persuasion. It's really a finesse job. So with this tool you can do that, and then once the pole shoes make contact with the frame, you can loosen and tighten the screw and fuss with it to make sure that they're square and seated properly. So this tool, by the way, this tool is not mine. Dave Larson loaned this to me. He used to be in the auto electric business, and it was originally designed for auto and truck starters and generators. It's quite a massive tool, and this tool was popular in an era before the widespread use of impact tools. So you can see that the people termed rightfully so hammer mechanics would basically use a big hammer to turn this into an impact wrench. It looks like at one point they knocked the wheel off the top and put it back on. But anyway, I thank Dave for allowing me to use this. I've got a spare generator I'm going to use it on when I assemble that. I managed to get a set of new old stock in the box field coils, and they came in a week or 10 days ago or so. And I have been waiting since December of 2016 for another set of those to show up. So thank you for those. This is a brush plate that I bought a year ago or more that's going in this generator. And new armatures are real easy to find, and they're reasonably priced for the Model 61 generator. I chose to run a uncaged needle bearing in this end cap. It has more rollers and provides, it will handle a greater load. This armature in the growler here, the end of the armature is worn, and very common failure back when I was wrenching. So I wanted to run a bearing that would minimize the chance of that happening. Oh, let's see. Let's do the growler. This is an interesting tool. Now I've got two armatures to demonstrate in this growler. One has a short that we induced with a small piece of solder right there. And I'm using this armature because these shorted armatures get hot quick and wouldn't be easy to demo. So let me just set the camera up so I can show you how this growler worked. By the way, this is the same growler that I used. Every generator that I worked on, the armature out of those had a chance to take a ride in this thing. This was used in the days before multimeters were real popular. And matter of fact, my first multimeter was a 110 volt plug in the wall. I think it had vacuum tubes. You need to warm it up. And so this replaced or preceded ohm meter testing, And let me set the camera up and show you how this thing works. I'm gonna use my Binford 6000 pole shoe tool to hold my camera so I don't have to keep putting it down. I think this will work. It may fall out of here. All right, here we go. The first thing I'm going to do is show you how to check for shorts. And essentially all you do, you turn the machine on and you hold a hacksaw blade above the frame of the armature. And if it's not attracted to the frame, then your armature is not shorted. So turn it on. Of course, now you can tell why they call this thing a growler. So this armature is not shorted. There's a continuity test that you can perform, this little light bulb, and you check the comm, and if it does not light the light bulb up, it is properly insulated from the frame of the armature. The next test is for open circuits in the windings, and you do that by shorting the segments across, and if you get a nice strong healthy spark, you have good continuity. If there's no spark or very weak spark, you have an open circuit. That's how that works. Plus, oh yeah, let me show you the short before I forget. So this armature is bugged and shorted. There you go. When the hacksaw blade sticks to the frame, the armature is shorted. One last little deal that this thing will do, which is kind of handy, is it will magnetize tools for you. So you can magnetize your screwdriver, you can demagnetize it, and that'll sometimes come in handy for pulling stuff out of tight spots. Well, that's it for these old tools. I've got some really neat stuff teed up in future videos on this machine that I'm anxious to show you, but for now we're going to stop and get back to work on this thing. Hey, thank you all very much for watching, and we'll do it again.